Hello, everybody. Today we're going to be talking a little bit more about proportionality, and that we will be talking about identifying and representing functions. Now, as you see there, the text that we'll be dealing with this particular part of our unit will be 8.5G, which has to do with identifying functions using sets of ordered pairs, tables, mappings, and graphs. Okay, so in those four different visual representations, we're going to look at what a function would be and what a function would not be based on several different factors. Okay, and the things that we need to look at are just around the corner. So let me go ahead and pull these things up. Now, as we saw in that description of the teaks, we will use mapping diagram, we will use ordered pairs, we will use a graph, and we will use tables to actually identify what is a function and what is not a function. So let's look at a mapping diagram first. Now, according to the rules of a mapping diagram, it says, and of functions for that matter, only one input value can be assigned to each output value. However, one output value can have several different inputs. Okay, with that all said, it just means that we can only have one input value, or X if you want to call it that. We can call it that, and one output value per input. Okay, so let's take a look about what a function would be in that case. Okay, so what I'm going to do is I'm going to go in just a bit here. I'm going to zoom in just a little bit. Okay, so again, we have our input and we have our output. So what would be a function? So in this particular case, I'm going to use a brown marker. This constitutes a function because that is one as your input or your x value, one as your output value. So that's 1 to 1. Okay, I'm going to go 3 to 3. That is one ordered pair. Now, and then we have this. Okay, so let me pull out what the ordered pairs would be. So if you notice, 1, 1 is your first ordered pair, and we'll make that again. Scroll that in just a little bit. Sorry about that. And I probably should write with a pen. And the only reason that I'm writing with a pen is so that you guys can see things a little bit better. Otherwise, I would be using a pencil. Okay, 1, 1. We then have 2, 6. We then have 3, 3. So if you notice, each one of your input or your x values has a unique number as your input. So that's 1, 2, and 3. Okay. So this would be a function because when I pull out those ordered pairs, each input again is only assigned to one output. Okay. And again, the x values are unique. Therefore, it would be a function. So let's show you what a function would not be in a mapping diagram. Okay. So if I take a look here, I'm going to just lay this over. So if I was going to look at this and I wanted to tell something that was not a function, okay, so what if we went ahead and we mapped 3 to 3, if I mapped 2 to 6, and then what if I mapped 1 to 1, then I took it a step further and I also mapped 1 to 3, okay? So let me pull out those ordered pairs, and again, I'm going to write with a pen for the ease of seeing this. We have 1, 1. I have 1, 3. I have 2, 6. And I have 3, 3. So let's take a look at our input values. I have a 1, 1 again, 2, and 3. So what makes this not a function is the fact that this one input value is assigned to not one, but two different outputs. So that is not a function. Okay. Now let's go ahead and move over to ordered pairs. Okay, since we've already been working with them. So again, I'm going to write with a pen so everybody can see this a little bit better. Okay, just picking up where I left off. What if I had and I'm going to put this one as a function here. and as a non-function here. And again, I am going to be tracing over this with a pen so you guys can see a little bit better. Okay, so function and non-function. So if I had the ordered pairs 1, 4, 2, 5, and 3, 6, what do I notice here that's going to tell me that these are functions? I have one input value here that is 1, another input value that is 2, another input value that is 3. So because of the fact that they are all unique, one input value is mapped to one output value, we have a function. So what is a non-example of a function? So let's take a look. We have, I'm going to use something that's very similar. So I have 1, 4. I'm going to use 2, 5 again. And then what if I switch it up and I use 1, 6? When I do that, you see that if I highlight my input values, that's 1, 2, and 1 again. So this particular input value, the 1, is going to be mapped to 2 different outputs. So therefore, not a function, a non-function. Okay? Now, I want to take a look at the graph down here. I'm going to move this down here. Now, when we are dealing with a graph, it's going to be fairly simple. All that we need to do is we need to look at the points on this graph, and I've already given myself a couple different things here. I'm going to show right over these. 1, 2, 10, 8, 6, 4, 2. I have 2, 4, 6, 8, 10, 12. So if I look here, I have several different dots. Okay, several different dots. If I were to use a straight edge, okay, and I'm trying to identify whether or not this is a function or not. If I had a straight edge, and if I were to pull this across my graph, what I'm looking for is that along the X grid, this is my X grid that goes up and down, okay? Along my X grid, how many points am I encountering as I pull this across? That's 1 point. I have 2 points. I have 3 points. So far, I don't have additional points along the X grid line, okay? Now what I'm looking for is to see whether or not there is a shared X value. And as I pull across, I now have 2 X values that are the same. Now because of the fact that I had 2 X values that are the same, then of course I do not have a function. So what would happen if this was not here, okay? So as I put my thumb over that, if I were to run this across again, I'm only encountering 1 at a time. I'm encountering 1 at a time. I'm encountering 1 at a time, 1, 1, so on and so forth, okay? But because of the fact that that dot was there, that shares an X value, so therefore it could not be a function. And let's prove that. I'm going to prove that by telling you what these points are. We have 1, 4. I have 2, 9 here. I have 4, 6 here. I'm going to skip these for now. I have 8, 7 here. And then I have 9, 4. Now let's see whether or not we have any duplicates of X value so far. 1, 2, 4, 8, 9, no duplicates. However, when I get here, I have 6, 7 here, and then I have 6, 9. So at this point, I'm showing that again, I have a duplicate of my X value, so therefore this is not a function. So it passed the vertical line test. Vertical line test is where I drag a vertical straight edge across to see whether or not I'm encountering more than one dot on one X grid line, and I don't. Up until I get to these 2 points, and at that point I see that they are sharing an X value or an input value, that is the same. X and input are interchangeable. However, we want to be most accurate by saying input. Okay, so not a function as it stands there. So I will write not a function. Okay, so now I'm going to move this over. So at this point, we're now looking at a table, and I'm going to give you a function, and I'm going to give you a non-function. So as we know, a table is simply a structured version of a set of ordered pairs that just happens to be structured in columns and rows. So let's look at, first of all, the example of a function. Okay, so let's look, and I'm going to share some of the ordered pairs that I used already. So just so you can see how this can be very similar. Okay, so now what I'm going to do is I'm going to give myself input, output. Let's go and draw a table over here as well. I know that this is imperfect. Doing my best to make it as neat as possible. Okay. Input, output. Okay. Now, just a second. I'm going to adjust this. All right. Move this little sleeve away. All right. So if we take a look here, if I were to put 1, 4, again, input, output, we have 2, 5, input, output. I have 3, and I have 6. I want to highlight the fact that, again, my input is all different. Okay, they're all different. They're only mapped to one output value. Now let's see what is not a function here. What is not a function? I'm going to do something very similar to what I did earlier. Probably the same values. They are the same values. 2, 5, and then 1, 6. So at this point, I'm looking. This is mapped to that value. This is mapped to that value. So far, so good. Then when I get down here, I see that one of my input values is mapped to a different number. So we have 2 shared input values. So again, this is not a function at this point. This is one of the finer skills that we need to develop in this particular unit. I recognize the fact that these are just the same visual. You guys have probably seen this visual. You have anyway seen this many, many times. So I appreciate you taking your time to take a look at this video and to refresh yourself on how to recognize a function. As always, if you have any additional questions, please ask me in class. If you also are not getting that question answered in class, you need a little bit more specialized attention, please come to tutorials or back this video up and watch it again. And as always, I will see you tomorrow.